Hello, pre-calc. Okay, this is my third take on this video. Things keep going wrong. It is going to be 3 pages, so you might want to take it a little bit at a time, maybe 1 page at a time. So last time we talked about sequences, which are just a list of numbers with a comma in between. Today we're going to talk about series where you have the sum of the terms in a sequence. A lot of S words in this chapter, so whenever you see all these plus signs, you're talking series. Okay, so it's a sum. And again, remember, just like arithmetic sequence is basically a linear pattern, the arithmetic series is also going to follow that. And a partial sum is when you're only taking a sum of a certain number of terms. So we're going to do a little derivation of where the formula comes from. And in the interest of time, I'm going to skip right to finding the sum of the first 100 numbers. And if you look at the pre-filled out note keys, you'll see there's a second example just to verify that this works in all cases. So if I want to find the sum of the first 100 terms, I'm going to start to list them out. Obviously, I'm not going to write all of them, ... And then we'll pick up with, let's say, 96 maybe, 97, 98, 99, and 100. Now that's a lot of work if we want to add all those numbers together. So we want to find a nice shortcut. Well, this is how it works. We take that first number and we pair it with the last number, and 1 plus 100 is 101. All right, nothing exciting there. Then we take the second number and we pair it with the second to last number. 2 plus 99, it's also 101. Let's see, does this keep going? So then we take the third number with 98, and we're finding there seems to be a pattern here. And this pattern allows us to kind of find a shortcut. So we use a capital S to represent sum. We are finding the sum of the first 100 terms, and what would that be? Well, I know that each sum is going to be 101 when I pair the numbers together, and by pairing them, it means I only had 50 numbers that I had to add up, but they were all 101, so that gives me a sum of 50, 50. So what did I do? Let's kind of generalize. So to find the sum of the first 100 terms, that 50, what did that represent? That represented my 100 terms divided by 2 because I paired them all up. And the 101, that came from adding the first term and the last term because all the other sums were exactly the same constant. And so we can then come up with our formula based on that. So S sub n is going to be whatever that n number is divided by 2, because you're pairing up all your numbers, times the sum of the first and the last term. Now it's a nice simple formula. However, you don't always know that last term. Now, in the last lesson, you did learn that in an arithmetic sequence, T sub n equals T1 plus dn minus 1, sort of like your linear equation. And so if I were to substitute that in, you would get a second version, which looks like this. So you still have n over 2, t sub 1, not t sub 1, because now I've also got the other t sub 1 here. So it's going to be 2 times t sub 1 plus dn minus 1. And this is the one you want to use when you don't know t sub n, Now the reality is I don't necessarily memorize that second formula. I mean, I've taught it enough that I kind of remember it. I don't recommend necessarily trying to memorize it. Just know that as you're using the formula and you're like, t sub n, I don't know t sub n, think about how would you find t sub n? You could use your old formula, figure out what it is off to the side, and then plug it in. That's typically what I would do. All right, so let's do an example. Find the sum of the first 40 terms of this arithmetic series. So when I look at that series, I know that n is going to be 40 because it asks for the first 40 terms. I know t sub 1 is going to be 60. I know my common difference, 60 to 54, 54 to 48 is going to be a negative 6. And I don't know t sub n. I don't know t sub 40. So let's find it out first. So t sub 40 is going to be t sub 1, my common difference, negative 6, n minus 1, which is 40 minus 1. And then using your calculator, that'll give you a negative 174. So we can put it all together. S sub 40 is going to be 40 divided by 2, 60 minus 174. And that will give us negative 2,280, which makes sense that it should be negative because you're adding successively smaller and smaller and eventually negative numbers. Okay, so that's it for the arithmetic series. So you have your S sub n equals n over 2, t sub 1 plus t sub n, unless you don't know t sub n. Okay, for the geometric, where you are multiplying each term by a common ratio, it also has a really nice derivation, which is kind of fun to walk through. So I'm going to do that with you. So if we have S sub n, that means, and it's geometric, so my first term is just my first term. The next term, however, takes that first term and multiplies it by the common ratio. The next term after that is going to be result from, again, multiplying by r, so it gets r squared. And then we would continue, so that then we'd have r cubed, and I'm not going to work it out infinity. Eventually you get down to plus t sub 1 times r to the n minus 1. All right, that's just kind of pulling out your partial sum. Now what I'm going to do is I'm going to multiply every single term on both sides by my common ratio. So that's going to give me r times s sub n. But I'm going to line up my like terms. So t sub 1 times r is going to go here. That would be the first term in the second line. So then the next term again, so now you're multiplying by r again, t sub 1, r cubed, dot, dot, dot. So this would then happen, but this term in the first line also got multiplied by r, so the last term is going to be r to the n. And now here's where the magic happens. So we're going to take those two lines and we're going to subtract them from each other. So what I get is s sub n minus r to the s sub n. The t sub 1 will come down. All these middle terms, because remember we're subtracting, are going to cancel. And then again we're subtracting. So this becomes minus t sub 1 times r to the n. And what I'm going to do is then factor out my s sub n and factor out my t sub 1. And then we want to isolate our s sub n. So s sub n is going to equal t sub 1 over 1 minus r times 1 minus r to the n. So the geometric formula is a little more involved. Now in your book, you'll notice that they always take this denominator and write it underneath this other part. I don't like to do that for several reasons. One, this first part to me is like a coefficient that's going to get distributed to the 1 minus r to the n. And so I find it easier to calculate that out first. And also when we start talking about infinite sums, you will find a little surprise that we don't need the second part of this equation or formula, 1 minus r to the n. So it just is my practice to leave it in front. You can do it any way you want, as long as you get the right answer. And also notice it's r to the n, not r to the n minus 1 like it is in the sequence formula, because we've multiplied r to the n minus 1 by r in the derivation. Okay, so let's go through and do an example. So we're going to find the sum of the first 6 terms of the geometric series 16, negative 8, 4, dot, dot, dot. All right, so we know that n is going to be 6, we know t sub 1 is going to be 16. Notice in this formula, we don't have to know the last term. I can see my common ratio will be a negative 1/2. Be very careful with that negative because that can really mess people up. So we're finding the sum of the first 6 terms. So that's going to be 16 over 1 minus a negative 1/2 times 1 minus, I would always put my r in parentheses, especially if it's negative, and then it's raised to the 6th power. Now because it's raised to an even power, the negative in front of the 1/2 is kind of superfluous, but if that 6th power were an odd number, then it would be really important to keep track of what that does to your sum. So what do I have here? I have 16, 1 plus 1/2, which is 3/2, and let's just work that out. Remember, you're going to have to invert and multiply, so that's going to be 32/3 as my coefficient, times 1 minus, so this is really, that negative's not going to matter because it's 6 isn't even, so this is 1/2, whoops, can't talk and write at the same time. So that's 1/2 raised to the 6th power. And then working that out on your calculator, you get a lovely 21/2, or some of you love decimals, 10.5. It's kind of cool how it works. Okay, just be careful with the negatives. Okay, so we have our infinite geometric series, as I was saying, and again, infinite just means it never ends. And you might say, well, how can you get a sum if you're adding numbers up and the numbers never end? How on earth can you ever get an actual sum of all those? And it's kind of cool how this works. I'd love to talk more about it, but this is a video, so we'll keep it short. So here's the key. Your common ratio has to be less than 1. So think about it. If I start with 10, and let's say I have a common ratio of 1/2. So I'm always going to be adding a number that is smaller. So first I'd have 10, then I'd have 5, then I'd have 2.5, then I'd have half of that, then half of that. Eventually, think about it, it's going to infinity. You're adding something that's going to have so many zeros in front of it that it really doesn't change the overall sum. This is how that works. And you're going to learn more about why this works in calculus. But for us, we're looking at the limit as n goes to infinity. T sub 1, 1 minus r, 1 minus r to the n. Okay? So if your r, and again in absolute value, doesn't matter whether it's positive or negative, that means that r to the n is approaching 0 because it's getting so much smaller and smaller and smaller as n goes to infinity. However, if your r is greater than 1, then r to the n is going to keep getting, it grows, what we say, without bound. It just gets bigger and bigger and bigger. And so kind of like a graph that's following an asymptote, it just keeps growing. So what I always like to write the little infinity sign here, though it's not really part of it, you don't have to write it. The infinite sum, therefore, is just t sub 1 over 1 minus r with the provision. That didn't look like a comma, did it? Let me make that better. So I'll say if, only if, your common ratio, doesn't matter if it's positive or negative, it has to be less than 1, so that what you're getting is you're adding smaller and smaller and smaller numbers so that you're eventually just adding 0. All right, so let's do a few examples. We want to determine, let's get a little terminology in here as well. If you do have a sum, so when r is less than 1, we say it converges to a sum, and that means you can find that sum. If the r is greater than 1, so again, that's when r is less than 1. If r is greater than 1, we say it diverges. In other words, it just keeps growing without bound. It doesn't approach anything in particular. Okay, so first thing you always want to do is figure out whether your series converges or diverges, because if it diverges, you're done. There's nothing else to do. So looking at this, 1/3 to 1, if you're not sure, go to the next one. It looks like we're multiplying by 3, and since 3 is greater than 1, this one diverges, and there's nothing to do. There's no sum to find. This next one, however, let's see, R, see I see a negative and then a negative, so when you see that oscillating, alternating positive, negative, you know R will be negative. Looks like we're taking 1/3 each time. So we know this one converges. What does it converge to? So that's where we're going to find our sum. So T sub 1 was 27 over 1 minus a negative 1/3. So that's 27 over 4/3, 1 plus 1/3. And again, we invert and multiply, so that's going to give me 81 divided by 4. Kind of cool. It's an infinite sequence. It's an infinite series that just keeps going, yet it has an actual sum. I hope you guys realize how absolutely, amazingly crazy that is. Okay, then on to one of my favorite things, logs. If you've ever had me before, you know I love logs. So sometimes when you're having to find n in these, in other words, you don't always know how many terms it took to get a specific sum, sometimes you're going to have to use logs. I know, your favorite. So let's do an example with this. Oh, you might also have to do the quad program. Well, let's do logs on this first one. So find n given the partial sum for that series is this. So we know the sum, and we know T sub 1. So let's write down some of this. We know that our sum, S sub n, we don't know what n is 425,971. Awesome. I know that T sub 1 is 13. Do you have to make this list? No, this is me always just kind of organizing my thoughts, okay? I know that R is going to be, it looks like it's going to be 2. Okay, now this is not an infinite. This is a partial sum, so it doesn't matter that R is 2, okay? We're not talking about diverging. This is just finding the n when you have a certain number of terms. Okay, well, that's interesting. What does that do for us? Let's put it into our formula and see what that does. We know S sub n is 425,971. Using our formula, we know T sub 1 is 13. 1 minus 2. And then over here we have 1 minus our R, which is 2, raised to the n. N is the big unknown. All right. Well, I guess I can start to peel away and isolate 2 to the n, because that's got my unknown on it. Aha, that should make you think, an unknown exponent. That's the whole purpose of logs. So what I have here, well, this right here is, this coefficient is 13 divided by -1. So what I'm going to do is just divide this by -13 over here, and that gives me some ugly number. Get my calculator out, but I'm also, well, I'll do it step by step. 425,971 divided by -13 is a lovely -32,767. So far that equals 1 minus 2 to the n. I'm also going to get rid of this 1. And I'm also going to then multiply everything by negative. So in the end, what I'm going to have here is 32,000, because they're both negative, it gets bigger. 32,768, because they were both, it's adding 2 negatives, so it got bigger. And I made it positive because I multiplied by a negative equals 2 to the n. All right, well, that's lovely. Again, how do you solve for an unknown exponent? You take the log of both sides. 768 equals n log 2. Because remember, the whole idea is when you take the log of a number, then that n can come down in front. So now I am free to divide both sides by log 2. This is kind of cool how this works, because when you do that, and I'm going to verify that I really do get that, I've got log entered the wrong number, 32, 768, 68, close parenthesis, divided by log 2. It's so satisfying. Look at that. It's just a nice, you'd think you'd get some weird decimal. No, spot on. So that sum is the result of adding 15 terms together. All right, very cool. Okay, let's do an arithmetic one. Let's see what happens there. The arithmetic one is the one where you're going to get a lovely quadratic. All right, so we have here, find n given this partial sum. So we know that the partial sum is 21,663. We know t sub 1 is going to be 97. We know our common difference is going to be, let's see, we're adding 4 each time. And this is one where we don't know t sub n. So I am going to actually use the other formula this time so we can have everything represented. So I know that 21,663 is going to equal n divided by 2 times t sub 1 plus my common difference, which is 4, times n minus 1. All right, that's setting up the problem. So our goal is to, at some point, have all my n's together. But let's start to simplify this out. So the first thing I'm going to do is I'm going to multiply this side times 2. And that gives me 43,326. That equals n times 2 times 97 is 194 plus 4n minus 4. And of course we can then combine our like terms. 43,326 equals, well, okay, I'll do it step by step. 194 minus 4 is 190 plus 4n, and then we are going to have to distribute our n. Dun, dun, dun. So notice, and I'm going to set this all equal to 0. I'm going to have 4n squared plus 190n minus 43,326. Have fun trying to factor that puppy out. Okay, what we're going to do, I know you guys don't have this. Some of you do, the TI Inspire people. I'm going to use my quad program because frankly, I think, and now that you guys are going to be in person, ooh, how will that happen? You all, if you have a grapher and you have the cord, bring your cord. What I'll do is maybe I'll sanitize some calculators and leave them out and you can just download the program. Because what I have here is if I use that A is 4 and B is 190 and C is negative 43,326 and I plug it into my lovely quadratic program, I get that n is either 83 or negative 130.5. Well, obviously n cannot be a negative number. That's just crazy because you can't add the absence of something. So we had 83 terms that gave us that particular sum. All right, or you can just plug it into the quadratic formula and you have a calculator. It's not that hard. All right, okay, if you're still with me, hopefully you took a little break. This is the last bit. Hopefully it hasn't been too heavy. On this page, we're going to talk about summation notation. And it's a shorthand way of asking for a particular number of sums. So how do we read this? Well, we have some place to start. We are going to start with the first term at n equals 1, and we're going to end when n equals 10. So we're going to find some, so this is going to represent s sub 10. And then notice this is the formula we're going to use. Now, if I was going to write this out, that's kind of annoying, but just to kind of emphasize this, I think you did have this last year. Like if n is 1, I know that I'd have 2 times 1 minus 1. If n is 2, I would have 4 minus 1, which is 3. If n was 3, you can kind of see what I'm going through. 6 minus 1, so that's going to be 5. And the idea is you're adding all these together, and you would get up until, you know, n is 10, and add them all, and that would give you your sum. That's crazy. That would take you way too long. There's always shortcuts in math, and it's always good to use them. So we know that if the formula comes to you and 3n minus 2, that's in y equals mx plus b form, we know that's a linear equation. So if it comes to you as a linear equation, we know it's going to be an arithmetic series, because remember the sigma represents a sum. And if you remember your formula, S sub n equals, I just had a momentary, like, what does it equal again? It equals this. So that's what we did on that first page. So in order to figure this out, I do have to do a little bit of work, more than you would with the geometric. I need to know what is t sub 1. So I plug 1 into my formula. 3 times 1 minus 2 is going to be 1. And I need to know t sub 25 because that's what I'm looking for. This represents s sub 25 here. So I plug 25 in. 3 times 25 is 75, minus 2 is going to be 73. Awesome. So putting it all together, I don't have to sit there and add all these out. I'm looking for the 25th partial sum of a arithmetic series that has as a formula 3n minus 2. So that's going to be 25 divided by 2, t sub 1 plus t sub 25, and then you would get 925 as your final answer. Okay, so look at your formula that they give you, and if it looks like a linear formula, then you can use your arithmetic series formula. Now for the geometric, it's actually a little bit easier, because this tells me I'm looking for s sub 5, and this is your t sub 1 times r to the n minus 1, which tells me this is geometric. So using my geometric formula, my t sub 1 is 81, my r is going to be 4/3, and then this becomes 1 minus 4/3 to the, I should put that in parentheses, to the 25th power. All right, and then I would work that out on my calculator, and you should get 781 as your final sum. I guess I should always box my answers, but I don't always, sorry. Okay, this next one, look at that. We're looking for infinity, but look at my r, it's 3. So no, I'm not going to find it because it doesn't exist. That one diverges because r is greater than 1. It's always a gift. Yes, we get to move on. So then this last one, again, infinity. So we're looking for an infinite sum. My r is less than 1, so I have to go ahead and do the process. So 24, that was my t sub 1. 1 minus a negative 1/2. So we've got 24 divided by, again, 1 plus a half is 3/2. So 48/3 is going to give me 16. And that would be that sum. All right. Okay, what if you are given your series and you have to write it in sigma notation? So let's see, I have 1, 2, 3, 4, 5 terms. 1, 2, 3, 4, 5. So I'm going to write my little sigma here. And I know that I'm going to start at 1, and there are going to be 5 terms I'm adding together. And when I look at this, I'm trying to see, it looks like this is geometric, and R is going to be 1/2, and my T sub 1 is going to be 1. So I'm going to put my T sub 1 goes here, and this is 1/2 to the n minus 1. So it's just your geometric series, or actually I should say your geometric sequence is the formula that goes here. So this represents your T sub 1 times R to the n minus 1. All right, now let's try one a little bit harder. So I have an arithmetic one here, 4 plus 10 plus 16, so it looks like I'm adding 6 each time, all right? But look at, in the middle I've got dot, dot, dot. What that tells me is I don't know n, right? I don't know the number of terms that I'm adding together. So I don't know what number goes on top of my sigma. So I'm going to have to figure that out. Well, I know that D is 6, positive 6. I know my T sub 1 is 4. In this case, I happen to know my T sub n, the last term, is going to be 100. It's always nice, although I didn't need that to know that, but that's okay. So I'm going to use my sequence formula. T sub n is T sub 1 plus your D times n minus 1, and I know that this has to equal, oh, actually I'm just going to, oh, I guess I'm coming up, I'm just going to set it equal to 100, right? Because we're trying to solve for n. I think on the other notes I did it in 2 steps, but I'm going to do it all in 1 step here. Okay, so I'm trying to figure out what this n value is. So I have 4 plus, let's just kind of simplify it out, and this all equals 100. All right, so I've got 6n minus 2 equals 100, so 6n equals 102. So amazingly, n is going to be 17. Awesome. Now that I've got my n value, I can do my sigma notation. So I know I'm going to start at 1, and I'm going to have 17 sums, and what goes here is actually going to be your simplified, and this is, you know, it's me labeling axes on a graph. This is another pet peeve of mine. You give me that as an answer and I'm not going to give you full credit. You have to simplify it. Actually, I simplified it here. It's 6n minus 2. And that would be your sigma notation. Okay? All right. Congratulations for making it this far.